Quite a while ago, I started learning CAD. I was inspired by other people like RC Testflight, who would design and then print RC planes, cars, boats, anything you can think of. Back then, this made me amazed. How could anyone just model an RC car and print it and just make it work? Now I see that when you don't fully understand something, it just seems like magic. After some digging, I found a program called Onshape. I answered a few questions, and that's it. Onshape is kind of strange because it's not actually a program that you download and use on your computer. It actually runs in your browser. Now, the thing about running in your browser is it doesn't use your full CPU potential, but most of the computing is done in the cloud. Onshape is free, but if you do use a free version, all of your files are made public, so be wary of that. Remember when I said I started this project in 2024? Well, that's because back then, I bought a 3D printer to motivate myself to learn CAD. Looking back at it now, I'd say it definitely worked. I got a lot better at CAD, but still had a very basic understanding of everything. I didn't work on the RC car for long, as just after I finished designing the rear, I accidentally snapped the motor's cables. I didn't have any tools to fix it at the time, so I slowly gave up on the project. But, as my dad always said, if you start a project, always finish it to the very end. August 23rd, 2025. I got back from holidays and started looking for inspiration. I highly recommend looking at other people's projects and designs and trying to recreate them when learning CAD. So I started to design the RC car. The steering was just one big block that used pivots that could rotate with the servo. The top secured the servo so it wouldn't move. After I got it down, I changed the base so it would have more space to hold everything. The back was probably the easiest part. I needed two holders that could hold the bearings in place. But after printing it, I realized when I tried to push in the bearings into the holder, the printed layers would separate. But if that didn't happen, the bearings would just slip out and rub against the gears, wearing them down. I made it so the axle had holes in it where I could put in screws and prevent the axle from moving side to side. I put all the parts together and let's see how it drives. Remember I said that the bearing slipped out and grinded down the gears? Well, that's what's happening here. Okay, so the RC car it's very fast, but you may have seen me having to push it to make it start moving, and that's because the motor I use it's a brushless motor that is used for quadcopters and RC planes, and isn't meant for, outputting much torque. Now, I haven't really talked about what I need to make this RC car drive. There's 5 parts: the battery, the motor, the ESC, the transmitter, and the servo. Now, the ESC pretty much just controls how much power the motor gets. It also gives the transmitter power, pretty much just powers the transmitter, and the transmitter can also use that power to power other things like servos, like other components that can hook up to RC cars. The battery is just a battery. It depends what one you get. Now, the RC car did have some cons. The front wheels were made from plastic, which means, obviously, it didn't have much grip. So if I turned, because I didn't have a differential, when I turned, the axle just wanted to go straight, and the wheels sometimes just locked up. I think it's understeer. It understeered, and it just crashed into a curb, or crashed, or just didn't work. Yeah, it's just complicated, pretty much. But the pros, there really aren't any. It just drives. Well, there aren't many differences between the first RC car and this one. So what are they? Well, I changed the gear ratio from a 1:1 to a 1:4. This means the motor has to spin more times to achieve the same RPM as the first RC car. I also improved the steering. I previously had a couple of 9-gram servos just laying around, so I just used those. I later discovered that they aren't built for durability, as crushing them caused the servo to jitter and glitch and kind of just like lag, which wasn't good for my RC car, so I just opted for the stronger one. Now, unfortunately, for the third RC car, I'd actually lost a lot of the files as I accidentally deleted them from my phone, and this will pretty much just make it so I can't really show much of the RC car, as most of the clips I have are either GoPro or maybe just like some photos I took, just reference images. And so I guess the third RC car will be skipped over like a little bit, because I'll just go right on to the fourth RC car and just tell you what I've done to it pretty much. I also bought some new rubber wheels, so we won't have any more traction issues to fix in the future. Now, unless you're an RC car hobbyist, you probably wouldn't have known that you have to glue the RC car tires to the rims, so when you're driving they won't just slip off. Now, I didn't know that, so almost for 2 RC cars I had used the wheels unglued, and it was really annoying to having to put them back on to the rim every single time you drive it. This is the RC car, pretty much. Yep, it works. Now, it's pretty light. Not really, but the steering works, which I'm happy. So, there's no differential, sadly, but I just want to test out and see how these gears work, because it seems promising. Yeah, so the front of it, obviously, we've got different servo, and it's on different pivots for the wheel holders. So now, it should work pretty well. I need new tires. I need a new axle for this. I've ordered like a metal one, like a metal tube, aluminum tube for the axle, and I'm gonna drill a few holes in it. But so far, it works really fine. And also, this happened. When it gets. Oh no! Well, that sucked, right? But let's see how it drives. After this, I wanted to swap out the axle for a differential. Now, if you don't know what a differential is, please look it up. It's a very, very simple concept, but it's kind of hard to understand how these gears turn and work. This just makes it so that the wheels can spin independently whilst getting power from the motor. And a good example of this is if you have an RC car, the reason when you would spin one of the rear wheels and the other one spins the opposite way is because of a differential. It's pretty much just using the gear that's on the right wheel, let's say, pushing off of the motor, I think, and then it's sort of like just turning the wheel the other direction because of the differential. Okay, so it's a weird concept, but pretty much I ordered it, and it took a lot of time to get here because back then I was kind of on a budget and didn't have much money, so I bought it from AliExpress.
But what the hell, boy?
Now, this brings me to my third RC car. You see, the shipping time was so long on the differential that I pretty much just ended up just starting to design the third RC car midway through the shipping. And I experimented with the suspension arms and linkages, and I got this. This is the suspension. I have a screenshot because I didn't save the earlier versions and I made it all in one file, so the version history isn't saved, so I just have a picture. Okay, so never mind. I actually opened the version history, and thank you Onshape for automatically saving the versions of the RC car, and I can pretty much just go back and see the progress over the days. This is this was the first suspension design. Would you look at this? And then this is the RC car, the full RC car. You see the steering mechanism is different. It's like a push rod, you know. Now over the next versions, there really aren't many differences, except for maybe some updates, some changes. But also I remapped the steering, as you can see. Now, I wanted both the wheels to turn at the same angle, but I couldn't do that because the linkage that pivots wasn't equal. So look, if I twist it, I look from the top, the angle of the wheels turning, they're both different. They're not parallel, you know. And also it varies when the suspension goes up and down. So that's just one thing to know. Now the cool thing is you can imagine it as a Minecraft lever or any type of lever. And that lever has a piston or an actuator on one side of it. So when you switch the lever, it compresses the actuator. That actuator creates resistance, absorbing the energy that is being pushed into it. And that's basically how an RC car works. It's just that torch, but it's on its side, and well, it's an RC car. And with that, let's see how it drives. tried to get a like front shot of the hot end melting and printing plastic, but it was too unstable to print an entire RC car, so I just printed a little duck. Now, of course, I don't record much of my builds and stuff, so I only have 2 videos of the RC car, working, and also have a video of it driving. But the thing about those 2 videos is that they're both in vertical format, so again, more black bars. Alright, so it's currently welcome to the end of the video. If you enjoyed, subscribe. If you didn't, don't. Now the thing I want to go over is looking back at my first RC car and my last RC car, there's a huge difference. Now me personally, I think that working on projects is the best way to learn CAD and design. It just teaches you so much, and if you don't know something, you can just search it up, how to do it, and implement it into your design. Anyways, see ya.